So when we report about measurements, we deal with fundamental physical quantities, length, mass, and time. Here we have some examples of lengths that we measure, like the distance traveled by light in 1 year is 9 by 10 to the power 15 meters. Like the radius of Earth, it is 6 million meters, 6 by 10 to the power 6 meter. Like the atomic nucleus, the diameter is 10 to the minus 14 meters. The diameter of the proton, a fundamental particle, is 1 femtometer, which is 10 to the minus 15 meters. So we need to be familiarized with this kind of measurements, and we need also to get familiar with these prefixes that usually we use to report about the measurements. For mass, this is the standard of mass in the SI system. Before 1965, different countries will have their own unit systems. In 1965, the scientific community have an international meeting in Paris, hosted by UNESCO, where they agreed on the accepted system of units that is used by the scientific community since then. So for length, we have the meter in the SI system. For mass, we have the kilogram. This is the standard of mass here, 1 kilogram. We use that standard to represent various masses. So here you can see a typical mass for a human is 7 by 10 to the 170 kilogram. The mass of Earth, 6 by 10 to the power 24 kilogram. The mass of an electron is 9 multiplied by 10 to the minus 31 kilogram. So the unit that we use is the kilogram, and there is the multiplier, as you can see here, that will allow us to express any mass, any measurement. The third fundamental quantity when we do physics measurement is time. And here the standard of time in the SI system, the unit of time, is the second. Okay, 1 second is the standard of time. So here some examples. In 1 day, there are 9 by 10 to the power 4 seconds. A typical radio wave period is 1 microsecond. For a nuclear collision, typical value 1 by 10 to the minus 22 seconds. Just to give you an idea about the scale of things that we measure when we use time. This is the image of the cesium clock that is used as a reference for time. Now, a few words about matter. If you take this piece of gold and split it into 2, the mass will be less for each one of them, but the chemistry will remain the same. The structure in each one will remain the same. If you keep dividing these segments into smaller and smaller and smaller parts, at the end you will get to the point where you cannot divide it any further. That is the limit for the so-called atom. Okay, so atom is the smallest amount of matter. Inside the atom, you will see particles, you will see neutrons and protons. Okay, so here ones are the orange ones. and neutrons are the gray one. And if you use high energy accelerators to break down protons and the neutrons, you will find inside them three particles which we call quarks. So protons and the neutrons are formed using quarks. Then a group of atoms here will give us matter. So it's good to have this understanding about the universe around us. Atom is the building block of all things. Each atom will have at the center a nucleus, as you can see. Inside the nucleus, there are neutrons and protons. And around the nucleus, there are electrons rotating in specific orbits. Collection of atoms will create matter. So here we have to learn also about approximation. So this is approximate values of some measured lengths, like the distance Earth to Moon. We round the numbers. It is approximated by 4 by 10 to the power 8 meter. You see the unit used for length is meter. The size of the hydrogen atom is 10 to the minus 10 meter. The size of the proton is 10 to the minus 15 meter. So it is always good to be able to use this approximation when you describe things. This is the fundamental building block for protons. We have 2 up quarks and 1 down quark. For neutrons, we have 2 down quarks and 1 up quarks. Protons and the neutrons are at the center of each atom inside the nucleus. When we do measurements, it is convenient to do dimensional analysis. It helps us to check on the equations, whether they are valid equations or not. So for length, when we measure length, the dimension is L, the unit is meter. This is in the SI system. Like for area, you have L multiplied by L, it is L squared. This is the dimension. The unit in the SI system is meter squared. Before the SI system, there was the CGS system. Length was measured in centimeter squared. There is also in the US system, you have the foot squared. For volume, dimension is L cube. SI units is meter cube. For velocity, the dimension is a dimension of length divided by a dimension of time. For acceleration, it is dimension of length divided by dimension of time squared. So when we have this understanding regarding the dimensions, we can use this information to check on the validity of equations. So for velocity, we expect dimension of length divided by dimension of time. So these here will help us, will guide us to check on equations whether they are right or wrong. So here velocity, it is dimension of length divided by dimension of time, or dimension of acceleration, length divided by t squared multiplied by time. Again, it is the same thing. So acceleration multiplied by time, yes, based on this analysis, this is a valid equation. Velocity can be calculated from the product of the acceleration by time. Okay, so now based on the dimensional analysis, we can verify that this is a valid equation. For x, it is dimension of length. So we can have it when you have length then time divided by time. Okay. This means if you take velocity and multiply it by time, velocity is length per time, multiply it by time, cancelled with t, so you have L in the right side. So yes, this equation is a possible equation. You take AT squared. For A, it is L divided by T squared. So dimension L divided by T squared here, multiplied by T squared. So you end up with L. So both VT and AT squared are accepted for measuring X. So when you have an equation for X, in the left side and in the right side, you have something VT, something AT squared that is valid from the dimensional analysis point of view. So here, if you say X equals half AT squared, yes, AT squared, this is dimension of length, so this is accepted.